Alright, welcome to this video everybody, and I'm going to show you how we can find the error in a slope or a gradient in a graph. So for this video I've got this data which I've made here. Now if you have a look at the data you might be thinking that this data looks too good to be true, and it is. So it would be very unusual to see a line that is actually that linear. But the key thing is that we can see that every data point has error bars which show the maximum and minimum values that could be obtained for both the x and y values. Now this particular data set was found is for an experiment where students were dropping a tennis ball from different heights, and then they were timing how long it takes to get to the ground. But then rather than making a graph of distance against time, they've made a graph of distance against the time squared to fall. Now the theory says that this should be a linear graph, and that the gradient of the graph should be half the gravitational acceleration, so half of g, which is 9.8. So we're expecting a gradient of about 4.9 in this particular case. So what we're going to do now is we're going to have a look at how we can find the uncertainty in that gradient. So our first step is to draw the line of best fit. So you always use a ruler when drawing lines of best fit, and I will even use one on this computer program. So as you can see, we've got a straight line that fits that data very, very nicely. But now what we need to do is we want to find the uncertainty in that slope. So when we're doing this, we want to find the maximum possible sloped line, the line of maximum possible slope that will actually fit all of these data points. So the maximum possible slope you can possibly draw is a vertical line straight up and down. But it doesn't matter where I put this line, it's never going to go through all those error bars. So instead, what I can do is if I instead just try to draw a line such that it will still go through all the error bars, I think the absolute steepest I can do is something like this. Now I'm just going to change color here for my maximum gradient line. So I'm going to claim this is about the maximum possible gradient that you can draw for this data set. Now, I'm claiming this goes through all the error bars, but note, it doesn't actually have to touch all the error bars. As long as it goes through the square that is outlined by the error bars, then it is still within error. So at this top corner here, it is still passing through that error bar, and similarly, for the bottom corner down here, it's still within the range that is allowed by that error bar. So that is what we call the line of worst fit, and it is the maximum slope. So I'm going to label this is line of worst fit, maximum. Now, when it says worst fit, it still fits the data. This red line does actually match all the data points, but it's just the worst possible fit that I can make to that data. Now I'm also going to do a line of worst fit minimum slope. So to do this, once again, I get my ruler, and I'm trying to draw a line of minimum possible slope that matches all the data points. Now there's no horizontal line I can draw here that's going to fit all those data points, but if I go all the way down from that bottom corner up to about there, that green line does fit all of the data points just. So once again, it's a line of worst fit, but it is minimum slope. Now once I've drawn in all these lines, I actually need to calculate the gradient of all these lines. So the line of best fit in blue and the lines of worst fit in red and green. So to do this, I can just pick any 2 points on the line, and then I draw a triangle. And then if I take the rise, how far it goes up, and divide it by the run, that gives me the gradient. So I'm going to calculate all these gradients. So in this particular case, I get the best fit line is 4.9 meters per second squared for its gradient. The max fit line is 5.2 meters per second squared, and the minimum fit line is 4.7 meters per second squared. So now, to find the uncertainty in my slope, I'm going to take my final gradient to be the best fit. So that is the 4.9 meters per second squared. But then, in order to find the uncertainty in that gradient, I'm going to take the max fit line and subtract off the minimum fit line and divide by 2. So in this case, the uncertainty will be 5.2 minus 4.7 divided by 2 equals 0.5 divided by 2 equals 0.25 meters per second squared. Now in this case, to get my significant figures correct, I'm just going to round this to 0.3. And so my final answer will be 4.9 plus or minus 0.3 meters per second squared. And that would be the gradient of my line. So then if I wanted to calculate acceleration due to gravity, it should be double this number. So my acceleration due to gravity in this experiment will be 9.8 plus or minus 0.6, so I double the uncertainty here as well, meters per second squared. And that is how we find the uncertainty in the gradient of a line.